Today's lesson is sections 5.2 and 5.3. It's about congruent triangles. Now, in order to do this well, the substitute's going to need to pause the presentation at certain times, especially when the students need to take down some notes so that they will have time to write it and then start it up again. You're also welcome to stop this at any time to discuss an example more or add some explanation. So please make it interactive. Hopefully this will work for all of you. Yesterday we were talking about congruent figures. And on congruent figures, you had to have all parts congruent, all side pairs and all angle pairs. So on a triangle, which is what we're going to focus on today quite a bit, triangles are congruent by less than just all 6 things. So if we can do just all the sides and no angles, that's a shortcut. If we can do all the angles and no sides, that's a shortcut. Maybe there's some combinations. So there are some ways we can get congruent triangles, identical triangles, without all 6 pair of angles and sides congruent. Well, the first idea is I was going to have you do a construction. Now you would need some measuring tools. I'm going to try and lead you through a few of these. If it's taking way too long, then you'll have to just move on. So for the measuring tools, I need you to draw a 4-inch segment. So get your ruler. I'll try and draw something up here for you to look at. Okay, then from one endpoint, construct a 2-inch segment. Well, how are you going to do that? Grab your compass and your ruler. Set your compass at how long a 2-inch segment would be. And then I'll just have to draw it up here so you can see what would happen. Put the point of your compass on one end of the segment you drew, and then make an arc, that 2-inch arc. Just draw it around there. So somewhere along that red arc will be a 2-inch segment. Then set your compass at 3 inches. Use your ruler to measure it. Then from the other end, make the arc that would be for 3 inches. Those 2 arcs should cross. And where they cross will be the last corner of your triangle. So create that triangle. Probably need to pause it so that they can catch up on doing the construction. Now, if you compare your triangle to some of the neighbors around you, take your paper and match them up. You should have identical triangles. Now, we've tried constructions, and some days it doesn't work real well for us. But think about what could be different. If we all used a 4-inch side, a 2-inch side, and a 3-inch side. Those triangles, there's no way for them to be different because if you change something, one of those side lengths would change. The triangle might be flipped over or it might be turned, but it's the same triangle. So by having all 3 sides congruent, we do always have identical triangles. So in terms of geometry, this is called the side-side-side congruence postulate. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. You'll have to pause this and let them take some notes. Then to explain that with a diagram, I'll slide it up a little bit. Okay, 3 sides of one triangle congruent to 3 sides of another. That does not mean that they're equilateral. What it means is they pair up. 1 pair, 2 pair, 3 pair. But without knowing any angles, we can get the fact supported that these 2 triangles are identical. They might flip or turn, but they are the same triangle. So we're going to be looking at a few diagrams, and I want you to figure out if the triangles are congruent. So in this one, again, pause if I'm going too fast. Are the triangles congruent? In this one, yes. Why are they congruent? It's by side-side-side congruence postulate. Now, a lot of what we'll do this chapter is matching up the triangles, and so I'm going to show you the triangle congruence statement. Triangle ABC is congruent to triangle. Now you have to match it so that the sides will match up correctly. AB needs to go with RT, then BC with TS, so it needs to be RTS. Are these triangles congruent? Now when the triangles are hooked together, it's going to work best if you will separate them. So I'm going to, off to the side here, draw the two triangles and mark them so that I can tell what's going on. A, B, C, B, C, D. Okay, what things are the same? AC is the same as DB. AB is the same as CD. Now that's all that was marked. But notice those two triangles are hooked together. This segment CB is the same length in both triangles. So the segment CB is the same as CB there. We'll be talking about that would be supported by the reflexive property, that a segment is congruent to itself. Now if you look at the two red triangles off to the right, you can see side, side, side. So are those triangles congruent? Yes, they are. And triangle ABC would be congruent to triangle AB goes along the 2 side, and then the BC is the 3 side. So I'd have to start at D, then go to C and B for it to match up. Another example, are the triangles congruent? Anytime you can stop this and let the students think before I start in on the solution. Okay, so again, I will draw those triangles separate so that we can mark them. Notice that above where I'm drawing, it says that M is the midpoint of RT. You're going to need to think about what that means. Okay, markings that were in the diagram, RS was congruent to ST, and that's all. Okay, think about that M being a midpoint of RT. If M is the midpoint of segment RT, then MR and MT will be the same length. So MR and MT are the same because of the definition of what a midpoint is. And the last thing to think about is, again, these triangles are hooked together. So this segment is the same in both triangles. And we get a yes again. They're congruent by side, side, side. Congruence postulate. Triangle RSM is congruent to triangle TSM. I have to stop and think, just like you. Okay, this is another investigation. Let's see if you can make some triangles. Okay, it says draw a 40-degree angle, and it says make the sides long. I'm going to scroll this up so that I have some room to draw it for you as you are creating it. To make a 40-degree angle, just start with a side, a segment. Grab your protractor, measure from one end, set your protractor there and measure around to wherever 40 degrees is. Make a mark there, then connect and draw through there. Hopefully that's about 40 degrees. It says measure and mark one side of the angle to be 3 inches and the other to be 4 inches. I don't have a good measuring stick in front of me, but let's say 3 inches comes about here, 4 inches, maybe here. So how do I make a triangle out of that? Connect the 3, the end of the 3 and the 4. So outside here, this is not part of the triangle. I don't know if mine looks exactly like yours or not. but it gives you a sketch to kind of see how it's put together. Compare yours to some neighbors and see if they're the same. Might need to pause this for a few minutes. All right, hopefully you've convinced yourselves that this arrangement of information does make congruent triangles. Now notice it's not all three sides. So what this is an angle, and the length of the sides on that angle are set. So when we have two triangles with this arrangement, it's going to be two sides, and we're going to say that angle is between the two sides. Notice how it's made up of the two segments that we have. This relationship, when we compare two triangles, is going to be referred to as side angle side congruence. Again, this would be a time to pause, and then I'll start up and give some more explanation. Okay, if two sides and the included angle of one triangle are congruent to the two sides and the included angle of a second triangle, then the two triangles are congruent. Okay, two sides. Let's say this side's the same in both, and this side's the same in both. And then it says the included angle, where the included angle has to be the angle that is made up of those two segments. So that angle right there is the included angle. And then the same picture over here, those two segments, the included angle is the one that is formed by those two. If those are congruent, the triangles will be identical. So now, are the triangles congruent? We've got two possibilities. It could be side, 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 or it could be side, angle, side. Okay, this one is a yes. You might have picked out side, angle, side postulate. And then triangle ABC is congruent to triangle SUT. That is two sides and the angle included between them. Next example, are these triangles congruent? You pause it. Okay, these triangles are congruent again. This will be that shared side. So when we draw the two separate triangles, J, H, F, and down at the bottom, H, G, oops, G, not J, F. Okay, originally I gave you JF congruent to GF, angle F congruent to angle F, and this HF is the same in both triangles. So again, we have yes, and it's side, angle, side. I'm going to skip the listing the triangles for a few examples. Okay, next pair, are the triangles congruent? Pause. So now, yes, they are congruent. Hopefully you picked out the two separate triangles again. Okay, we've got angle side ABC. Okay, that is a right angle. And then CBD. Oops, I put D in the wrong place there. Okay, ABD is a right angle, and CBD would also have to be a right angle because they're a linear pair. Segment AB congruent to segment BC. That shared segment BD is the same length again. So looking at the pictures, do you see the right angle is made up of the two sides that are congruent? So we have a yes, they're congruent, again by side, angle, side. Another example. Looks like I forgot to label this one. Okay, they're not really hooked together that it's confusing, so I think we can just leave the diagram the way it is. Is there anything you can come up with besides the tick marks that are there? one thing that we can support is these two angles are congruent. Why? Vertical angle theorem. Vertical angles are congruent. So we do have the two sides and the angle that's included between them in both triangles. So are the triangles congruent? Yes, they are. Again, it's side angle, side congruence. Okay, so far we've had side, 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 and side angle, side congruence. Oh, looks like I have one more example. Are these triangles congruent? Okay, what do we know? Okay, correct. Segment NO is congruent to segment MP. And, all right, good. They share that segment. So that's the same in both. Okay, now we've got something different to think of. See these parallel markings? So if that top line is parallel to this bottom one, and I'm going to highlight the slant for the transversal, can you focus on that Z? Notice we have alternate interior angles that would be congruent. That would be this angle, and then down here, this angle. So looking at the triangles on the right-hand side that I've pulled apart, do you see side angle side again? So we can come up with some things like vertical angles, reflexive, alternate interior angles. Those are some things that we can add to the diagram. Okay, now based on time, you'll have to see if you have time to do this next one. We're probably a little more than halfway through the lesson. It says draw a 3.5 inch long segment, and I'll draw that up above for you. Okay, let's say that segment's 3.5 inches. It says at one end, we need to measure and draw a 70-degree angle. So on this end, grab your protractor, measure around to 70 degrees, and draw that segment. I don't know how long to draw it, so I'm just going to go out quite a ways. Then from the other end, it says make a 30-degree angle. Okay, so from this point, protractor 30 degrees, might be about there. And draw the segment to finish that angle. How long do I draw it? I don't know. Looks like I'm going off the screen a little bit. Okay, so you do get a triangle formed. And if you think about the length, that length can't change. The angles are set at 70 and 30, so again, this will produce some triangles that are identical. Maybe flipped over, but they're the same. So that relationship has two angles and a side. The side, when I made that construction, was between them, because I had that side, and then the angles were on the ends of that starting segment. So that segment is considered included between the angles. The angles are on the ends of it. Kind of like a barbell, I guess. So if that helps you out, the wording, you'll have to pause it so that you can write it down. If two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. Get it in your notes. All right, let's see if we can come up with some examples. Are these triangles congruent? Got a side that's the same in both, and on the ends of that segment there are the same two angles in both triangles. They are flipped the other direction, but it is the same information. So we've got yes, by angle, side angle. These are congruent. This is a postulate. Are these triangles congruent? What do those arrows mean? Notice that doesn't mean congruent, it means that they're parallel. What we did in a previous problem with parallels was we came up with some alternate interior angles that are congruent. So to pull this one apart, let's draw the two separate triangles. We've got RST, we've got RTU. Okay. Oh, you're right. That segment right there is the same in both of them. So RT and RT, that's the same. Good job. All right, let's look at some angles. At the parallel, take the transversal, and then the other parallel. So in blue, these are alternate interior angles that are congruent. So that would be the angle R in this triangle and the angle T down here. I'm going to switch to the only color I have left, which is black. So let's do the left hand parallel, take the transversal, the right hand parallel. In black, can you see these two? Those are alternate interior angles also, because we have parallels both ways. So that would be this angle R and this angle T. So after we've thought through that, are the two triangles congruent? Yes, again they are. It's angle, side, angle. All right, got to do some thinking. Are the triangles congruent? Reflexive, that segment's the same in both. All right, what's this part over here mean? What's it mean if you bisect an angle? Okay, you're cutting the angle in half, is correct. All right, so we got the reflexive segment. Okay, so if we're cutting angle ADC in half, that means ADB and BDC are the same. We're also bisecting angle ABC on the right-hand side. So if this angle is cut in half, then these two are equal. When we get that into our separate triangles, are you seeing angle, side, angle again? By angle, side, angle congruence, we do have two identical triangles. The fourth one for today is almost like the last one, but the difference is the side is not going to be included between, it's not going to hook those two angles together. So if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. Again, pause so that you can write notes. Okay, so what's the diagram going to look like on this one? I'll slide it up a little bit. Two angles. Let's do it kind of like those last pictures. There's two angles, but the side is not the side that's included between the two angles. So I'm going to say this side on the left is not included between those two. Notice the angles aren't on both ends of it. Then if I compare it to my other triangle, this would be the corresponding one in that triangle, the matching one. This is a picture of angle, angle, side. It's two angles and then the side that's not between them, but it's on one end or the other. If you wrote it as side angle angle instead of angle angle side, that's the same thing. I'm in the habit of doing angle angle side just like your textbook is. So that's the way that we'll say it. Okay, so are these triangles congruent? Right now you have 4 different possible methods. This is a yes, just like the theorem we're on. It's two angles, and then a side that's not between them. This one is a theorem. The others were postulates. Are the triangles congruent? What can you add to it that's not there? Should be the vertical angles that you can add. So now if you'll cover up one triangle at a time to help you focus, notice it's two angles, and there's a side, but it's not the side that hooks those angles together, so it's the non-included side. If it were the included side, we would put the S between the two A's. So this is the non-included side. Are they congruent? While you're thinking, I'll draw the triangles separately off to the right. Okay, you ready? We've got angle C congruent to angle B. Okay, someone probably got that reflexive for you. And there are some parallels, but be careful, it's only one pair, not two. So follow those correctly. So we've got this top angle congruent to this bottom angle. So on our green triangles to the right, did that side end up between the two angles? It is not. The angles are not on the ends of that segment, so it's called a non-included side. So this still is a yes. It's by angle, angle, side congruence. So the difference between the angle, side angle, and angle, angle, side is where the side is. Is the side hooking the two angles together? Are the angles on the ends of that side or not? Otherwise, side, side, side's probably the easiest to see. Side angle side is directly hooked together. Angle side angle, the things are directly hooked together. Angle angle side kind of skips over a piece. An angle, then another angle, and then the side. So there's a difference. Okay, so your sub can take you through the check for understanding depending upon what time you have right now. The answers are in the teacher book. There are 2 different pages because this lesson actually came from 2 different sections. We'll discuss those and check on those if you have time, and then you will be given the assignment to work on for tomorrow. Hope this worked well. If it didn't, check your book. Your book has information just like what I was giving. Okay, see you next time.